So exercise 15L, I said I would go through. Normally I have my calculations in front of me so I don't have to waste time showing you the calculator usage. So I'll just have to sort of do those calculations as I go along. So forgive me if I'm a little bit slow in places. So exercise 15L, question 3. Regulations in a country insist that all mineral bottles that claim to contain 500 mils must have at least that amount. Yummy Cola has a machine for filling bottles which puts an average of 502 mils into each bottle with a standard deviation of 1.6 mils and follows a normal distribution. Okay, so let's go. So this is exercise. And if you're okay with 15L and you don't need to see a solution to it, then feel free to complete other problems from exercise 15L or go to the revision, or you can go to exercise 15M if you prefer to just chart your own course. That's fine. Okay, so first of all, let's set it up. So let X be the random variable capacity of a bottle. In other words, the number of mils in the bottle. Then X is distributed normally with a mean of 502 and a variance of 1.6 squared. Okay, so there's the setup. Any questions yet? Okay, so it says it says here that the regulations insist that all mineral bottles must have at least 500 mils in it if it claims to have 500 mils. So part A says an inspector randomly selects a bottle of Yummy Cola. What is the probability that it will break the regulations? Well, if the regulations are that it needs to have at least that amount, then we are looking for the probability that X is less than 500, like so, which is a straightforward calculator operation. So again, I don't have my calculations in front of me, so I'll just have to do it again. So on my graphics calculator, I will go menu 5, 5, and I'm looking at a normal CDF, so number 2. And we've got X less than 500, so we leave the lower bound as negative infinity, whatever that big number is, big negative number is, and the upper bound is 500. In this case, the mean is not 0, but 502. And the standard deviation is 1.6. Okay, so I've done all that on my calculator, pressed enter a couple of times, and I get 0.106 through 3 significant figures. Seems pretty high to me. 10% chance of it not being the right capacity. Okay, is that okay so far? Okay, part B. What proportion of bottles will contain between 500 mils and 505 mils? Now, the word probability is not there, but the proportion will be effectively a percentage, right? So it will be effectively the equivalent of the probability, because the percentage of it being between 500 and 505 will be the same as if you had a sample of 100, then you would expect that number of bottles to be between 500 and 505. So the proportional probability is the same thing. So we have the probability that X is between 500. So put 500 in my lower bound x and 505, like so. And that is equal to, calculator usage again, menu 552, lower bound this time is 500, upper bound is 505, the mean is 502, and the standard deviation is 1.6. So that's 0.864 to 3 significant places. Okay, so that's straightforward calculator operations as well. Any questions about that? Okay, C. I'm going to put C on a new screen, so I'll just zoom out and I'll leave it zoomed out for you. So for C, we have, it says 95% of bottles contain between A and B milliliters of liquid, where A and B are symmetrical about the mean. So what are A and B? So if I just draw that diagram first, there's the mean there, which is 502. Just double checking that from the information given. So there's the mean there with 502. We're told A and B are symmetrical about the mean. In other words, they're the same distance away from the mean as each other. So that's okay. And it also says it's that covers 95% of the bottles. So, you know, you'd probably be looking at A being about here, and symmetrically, you're looking at B being in there. And it says what is A and B. So we know that the shaded area here is 95%. Okay, so we're going to use just a little bit of logic for this one. First things first is, if I go probability of X, probability of X being between A and B, like so, equals 95% or 0.95, I could work that out and figure something out, but I think what I would rather do is I'd rather take the opposite case, because I think I can work out what A and B are separately there. I'll show you what I mean. I've got the probability of A, start that again. The probability of X less than A plus the probability of X bigger than B, given they're symmetrical, or not even given they're symmetrical actually, must be 1 minus 0.95. Is that okay so far as a first step? So I'm looking at the complementary, or the complement of those sets. So if this is everything and that's 95%, then the bits in white here must be the 5%, or 1 minus 0.95. Okay, this bit and this bit. So that's all right. So it kind of helps us a little bit in that we've got we've got 0.05 here, but we've still got two unknowns on the left-hand side, A and B. So let's use the properties of symmetry there. And what I'm going to do is slightly different to what I showed a couple of people yesterday, actually, but I think this actually makes more sense in terms of a normal distribution, is I'm going to say that B, so for some value, I'm going to use lowercase x, for some value of x, B is equal to 5.2 plus x. Yeah, just some value more than 5.2. I can't even read my own writing, it's a bit dodgy. 502. I'm going to write that in neatly here as well. 502, Richard. And must be 502 plus some value of x, a positive value. Okay? And A, being on the left of 502, and given that it's symmetrical, must be 502 minus x, because they're symmetrical. Okay. So, and the probability of x less than A must be equal to the probability of x greater than B. So this is just the setup. Same reason, because they're symmetrical. Okay, good so far? So they're the same value. The probability of x less than A is the same as the probability of x less than B. Okay, let's put it all together then. So we're going to use those facts and put them all together. So first of all, so therefore, probability, of x less than A plus the probability of x greater than B is equal to 0.05, which gives us the probability of x less than A plus the probability of x less than A equals 0.05. Okay, so that's from the fact in slide 2. It must be the same thing. Now I've got 2 times that number, so it's 2 times the probability of x less than A is equal to 0.05, which means the probability of x less than A must be equal to 0.05 divided by 2, which is 0.0025, unless I can't calculate things. 0.025. I think I said 00 then. Okay, I'll stop there for a moment and ask if there are any questions. Okay, so that's making sense so far, or you're too shy, one of the two. Now we're going to use our calculator to work out that inverse, the inverse distribution function. So I'm going to go menu 5, 5, and then I'm going to do 3 for inverse normal. The area is 0.025. The mean is 502, and the standard deviation is equal to, what was it, 1.6? 1.6. Sorry, you can't see this on the screen. I've been trying to get the software, but it's not working for me. So that's given me a value of 499 to 3 significant figures. Okay. So what does that mean? Well, A equals 499. Up on slide 2, I said that A is 502 minus X. So now we're just having a look at the number of mils away from the mean it is. That's all, because we'll need that for B. But we've worked out what A is. And you can do this intuitively, I suppose. But I just wanted to have a bit more of a considered approach to it, i.e. 502 plus X is equal to 499, minus X. Okay, so that's from slide 2 there. And that means that X is equal to 3. Therefore, B, which is 502 plus X, is equal to 505 mils. and then we're done. So what made this special, and you'll see this a lot in exam questions and all that kind of stuff, is that you needed to use your understanding of distributions, proportion, and therefore what proportion means, understand the concept of symmetry so that you could pull all of this together. That is basically how you would approach question 3. Elizabeth?
Because we can't show our calculations on the graphics calculator, do we do that thing? And then we can start moving.
Not easy. So Elizabeth's asking just a technical question on how you show that working out in a in an exam. From what I've looked at through the mark schemes, they seem to assume that you've used a calculator to get between steps, really. If you want to be really good about it, and I don't mind this at all, you could just go by GDC in brackets like that. That would be fine. If you just want to make it really clear where you're getting your results from. And in terms of, so let's move away from exams and just talk about, in general, good practice there. By putting a comment to the side by GDC or by calculator, it just means if someone else was reading your work, if you're part of a team who's doing calculations on a particular, you're part of a research team or part of some sort of scientific team, then by sort of annotating your work with, by calculator or something like that, would mean that the person who's reading your work would be able to know, oh, okay, so it wasn't just pulled out of thin air. And then if they didn't know what you meant by calculator, they could at least find out from you. So it would be a flag to them about how you went about your process. So I don't mind that at all. All right, can we now flip to exercise 15M? What makes 15M special? I'm keeping you up, Ashley. What makes 15M special is that the only way to solve it is to change your normal distribution to a standardized normal distribution. So we're going to have to practice those skills a little bit in order to do it. So I'm going to do question 1 and 2 for you right now, and you're going to do 3 and 4 by yourself. Then I'm going to do question 5, and then you can have a go at doing the rest of them for some time. So see how we go. I'll try and be fast, but just tell me to slow down if you're not too sure what I'm doing. So question 1, we are told that X is distributed normally with a mean of 30 and an unknown variance, so sigma squared. We're also given the fact that when that random variable is greater than 40, the probability is 11.5%, 0.115. Okay, they are the facts, and we need to find what the variance is. The standard deviation is in this particular instance. So we have no calculator operation that will give this to us straight up. Okay, because we have to fill in, to use our calculator, we have to use our, we have to fill in the mean and the standard deviation. Okay, so the inverse assumes we have the area, and then the straightforward functions assume we have the mean and the standard deviation. So it doesn't really help us at all. But what we can do is we can reorganize our normal distribution by standardizing it, because we know that if it's standardized, then it has a mean of 0 and a standard deviation of 1. So let's get this going. So a bit of preparatory work first. The probability that X is greater than 40, we can't deal with, as you know, but we do know that the probability of X less than 40 must be 1 minus 0.115, so it's 0.885. Okay, so that's the complement. Alrighty, so what we're going to do now is we are now going to standardize our normal distribution. So we have a formula, which is that the standard variable Z is given by x minus the mean all over the standard deviation. That's the conversion rate. Okay, in this case, x is 40. That's our boundary. That's why we chose it. The mean is 30. We're given that in the problem. And the standard deviation, we don't know. I'll probably do that a bit better. No, I can't. Okay, so we've got 10 over sigma is equal to z. Good so far? Going to zoom out now and just keep writing in slide 6. So that means that the probability of x less than 40 is the same as the probability of z being less than 10 over sigma. This is sigma in this case is the sigma of the normal distribution, not the standardized one, which is just 1. Okay, so the probability of z is 10 less than this value sigma is equal to 0.885. Okay, so now that we've standardized it, we can use our standard distribution. So on our calculator, you might want to follow through with this if you're not too sure where I'm going with this. On a calculator, we are going to go to menu and then to Prob 5 and then 5 again to get our distributions. Okay, now we are going to take a normal CDF, so that's number 2. The lower bound is negative infinity and the upper bound, sorry, beg your pardon, wrong, I went too far then. Let's escape that a bit. Menu 5, 5, we're going to do the inverse normal because we've got the area, 0.885, and we need to work out what A is, Z less than A. So sorry about that. So choose inverse normal, which is number 3. The area is 0.885. And the default values of 0 and 1, we leave there because we've standardized this normal distribution. So if I press enter a couple of times after 0.885, you should get 1.20. So what does that mean? It means that 10 over sigma is equal to 1.20. I'm going to leave that whole value there in my calculator because I think I'll use it a few times there. So I'm writing it down to 3 significant figures, but I'm keeping the full value in my calculator. Just stop there for a moment and make sure you're okay. So the tricky thing, not tricky really, but the important thing to point out here is that we are just treating this bit that I'm circling now on the screen, I'm treating this bit like A, because it is. Just because it looks complicated doesn't make it different. It's just A. Okay, so Z less than A is equal to 0.885, therefore A equals 1.20. It's just that A looks different. Alrighty, now we have an equation we can solve because it's only got one unknown there. So I'm going to do this in I'll do it in 2 steps. You could do this in 1 step though. I'm going to multiply both sides by sigma, and that'll get me 10 is equal to 1.20 sigma. And then I'm going to divide both sides by 1.20, although I'll use the exact value in my calculator. And that'll get me the value of sigma. So sigma is equal to, on my calculator, I'm just going to go 10 divided by, and then I'm going to go control minus for the answer there. So 10 divided by the answer is equal to 8.33 to 3 significant places. And hopefully that's the answer in the back of the book. So that's basically it. That's how you do it. So we're going to standardize, and then we are going to solve for the unknown. I'm going to do question 2, and then you're going to do 3 and 4. This is the time to ask questions because I'm going to do this one faster. So if you've got questions, you better ask now. Okay, same technique though. Question 2, you can see it's the mean that we're missing, but it's the same technique. So let's set it up. I'll just zoom up just for the first page so you can sort of see it. I'll zoom out in a second. So question 2 says X is distributed normally with an unknown mean and a variance of 4 squared. And we're told that the probability of x less than 20.5 is equal to 0.9. So there are our facts. Now this time, because we've already got x less than, we don't have to sort of, find the complement or anything like that. So let's get stuck straight into it. So z is equal to x minus the mean over sigma squared. Sorry, over sigma, not sigma squared. Okay, so it doesn't hurt to put the formula down until you've got it right in your head, I reckon. X in this case is 20.5. Mu is unknown, the mean is unknown, and sigma is 4. So we've got that. And we're kind of a bit stuck. We can't really do too much more. Not without it being particularly useful. So therefore the probability of z less than 20.5 minus mu over 4 is equal to 0.9. I'm going to zoom out now so you can sort of see it as I move on to slide 8. Okay. Using our calculator, you can use the inverse distribution function, and you can put in 0.9 as the area, and that'll give you a value of 1.28, just jumping ahead there. So therefore, 20.5 minus mu all over 4 is equal to 1.28. That's just from your calculator. So now we're going to solve. So I'm going to use the full value in my calculator. So I'm making it as accurate as possible, but I'm going to multiply both sides by 4, and that'll get me 20.5 minus mu is equal to 5.13. And then what I'm going to do is I'm going to subtract 20.5 and then turn everything, and then change the signs to make mu positive. Or if you like, I just don't want to write all this down. I'm going to add mu to that side and subtract 5.13 from that side. So it gets me mu equaling 15.4 to 3 significant figures. There we go. So that's how you do it. So you start off by using standard distribution, changing it to a standard distribution, and then solving for mu or sigma, and then you're good to go. So do questions 3 and 4. I'll give you, 5 minutes tops to do that, but I'll move faster if I can. So do questions 3 and 4, and I'm going to come back and show you question 5 in about 5 minutes time. So to see how much you can get done. Later. So this is question 3. We're just having a look at the approach. So I'm not going to do a proper proper solution, but probability of x greater than 58.39 is equal to 0.0217. So what I would do is I would take each probability calculation separately and then bring it all together in the end. Some of you have done it side by side, and I'm okay with that, but it's probably just not how I would do it personally, that's all. So the first thing I would do is I would then work that out to be, therefore the probability is x less than 58.39 is equal to 1 minus that, 1 minus 0.0217. Oh my gosh, you should see what's happening on my screen here. It's not pretty. Okay, so 1 minus 0.0217. Can you not talk while I am? It's a bit rude. 0.9783. So 0.9783. Then I would work out the the standardized normal distribution, and then calculate as usual. So I'll do it with that one. And when we do that, we get 58.39 minus an unknown mean over an unknown standard deviation equaling 1984. Good year that. Similarly, I would take probability of X less than 41.82, which it says is equal to 0.0287, and then I would find out, I would standardize it, work out what the inverse is, and I would get 41.82 minus mu over sigma is equal to negative 1.003. Thank you. I wouldn't normally go for that accuracy even when I'm writing it down, but because I don't have them in my calculator already, I'm just dealing with it like that. So then I guess the important thing to point out is just how to use your calculator from here. So remember, this is a calculator-based question. This couldn't be asked in the non-calculator section, could it? Because you've had to use your calculator just to get this far. So we might as well keep using our calculator. And so I'm just going to quickly teach you how to solve a system of linear equations. Well, I don't know if they have to be linear. Yeah, they'll probably do a system of linear equations. So on your calculator, if you go to hit the menu button, this time you're going to hit 3 for algebra. And the list of 3 options there, it's the number 2 there, solve system of linear equations. So hit 2. And it says number of equations 2 and variables. Now this is where you can just use your common sense. Yes, you can change X and Y to sigma and to mu and sigma if you desperately want to have the same pictures there. But as long as you have it right in your head, you're okay. So I'm going to use X for mu and I'm going to use Y for sigma. Okay, X for the mean, Y for the standard deviation. Just keep it right in your head. So once you've made that decision, press OK, and you should get linsolve with a bracket, and it's waiting for you to type in the equation in the top box there. So I'm now going to type in equation 1 here. So I'm going to label it. So from equation 1, I'm going to type in 58.3. Oops, got to put it in brackets. Sorry. I'm going to type. I'm sorry you can't see this, but I'm going to go bracket 58.39 minus. Remember, I said X was going to be used for the mean, so minus X close bracket divided by Y equals, where's the equals button? There it is. Equals 0.0287. No, sorry, 2.1984, sorry. Oh, 2.01984. Thank you. Oh, 1984. There we go. And then I'm going to press tab and I'm going to use my brackets again for the numerator. So 41.82 minus X close bracket divided by Y, because I'm using Y for the standard deviation, equals, and then I'm going to have negative 1.90025. I think that's everything. I'm going to press enter. I haven't used this before, so hopefully it'll work. No, didn't work for me. Did it work for you? Okay, so you do need to manipulate it a bit. Okay, so that was the question I had. So sorry guys to lead you a bit astray there. So from 1, just a slight bit of manipulation here. So we're going to have 58.39 minus mu is equal to 2.01984 sigma. So here I'll just multiply both sides by sigma. And from 2, what was it? 41.82 minus mu is equal to negative 1.90025 sigma. And these are the ones that you'll put into your calculator. So I'll just put that in. So I'll call out as I'm reading it. So menu 3, 2, enter. So my lin solve is going to be 58.39 minus x equals 2.01984y tab, and then I'm going to have 41.82 minus minus x equals negative 1.90025 y, and then I'm going to press enter, and then I'm given my coordinates there as 49.8 or 49.9 and 4.23. So the first one will be the x coordinates, that's mu. So therefore mu is equal to 49.9, and sigma is equal to, this is the y coordinate, 4.23. Okay, both of those to 3 significant figures. Okay, so if you want to see it on my calculator screen, ask me, or if you can't get it to work on your calculator, please ask me about it as well. Right, so what I didn't get a chance to do is show you question 5, nor did I give you a chance to have a look at an exam style question. So what I will do is I'll stop this video here.